welcome back to week 5. As you can see, I'm neither in the lab or in my office today. They were doing some construction over on Patton Building, and it just wasn't advantageous to be over there at the time. So I'm recording from home for the last few videos. So not sure if it's going to change in the future or what, but Monty's downstairs having lunch. So don't worry, he'll be back to join us a little later. So just to let you know. And occasionally you might get a cameo from either my son or my cats. So just a heads up. Anyway, with that said, let's go ahead and talk about chapters 20 and then move on to chapters 21. So today we're going to be talking about the kidney. So a lot of people, there's a misconception about, and I've heard this before, that, you know, if you're exercising or you're sweating things out, you're sweating out toxins. And that's actually incorrect. The only thing that can get rid of toxins in your body is your kidneys. That's why your kidneys are so crazy important. And we're going to be going over that, why they're very important, in conjunction with actually breathing, as I mentioned last week when we talked about respiration and the respiratory system. Both breathing and your kidneys work to keep your blood at a certain pH, which is actually quite clever, the chemistry dance that they do to actually make this work. And we're going to talk more about that chemistry dance in chapter 21. And I'm just going to kind of introduce you to the kidney and how it works. And there's a lot of interesting words in this chapter that some people get a little overwhelmed by. So please, definitely go through your book and go over the vocabulary pretty well on this, because a lot of people, what was it, exam 5, I believe, they hit this one and they kind of go, and it's not as complicated as it seems. It's just kind of an interesting way your body goes about cleaning out your fluids in your body. And we'll get into that right now. So without further ado, let's go ahead and talk about your kidney. And if you remember, I don't know if you're as old as I and you remember Charlie the Unicorn. I'm getting older and older, I find, when I pull out the old memes of the Wild West, when the internet was the Wild West. And the memes were strange. Anyway, so remember, this all boils back to homeostasis. So remember, that's maintaining, situations the same inside of your body. And this time we're talking about our bodily fluids. So this is where the urinary system comes in to help us completely keep homeostasis there, but it's also where the respiratory system joins in here. So these two systems are very much together, even though it doesn't feel like they should be. You know, I mean, it's breathing and then the urinary system going to the bathroom. How can they in any way be related? Well, it's to maintain our blood pH, which is usually around 7.38 to 7.42. And interesting fun fact, it's about the same pH for seawater, depending on what's going on with the environment at the time. So we are ourselves, and this is something I like to point out in general biology too, we are our own little oceans upon ourselves. So you are your own walking, talking ocean. And we've got to maintain that pH for this ocean to work. So, however, when you exercise, when you break down all that glucose from the muscle cells, working out, which is a byproduct, your blood pH starts to drop and it turns acidic. And that's not cool. We need to balance that back out. And because if we get, too further down this way, we can get into acidosis. And if we get too high and too basic, we get alkalosis, And we'll get into those later. It's actually very dangerous to go outside this range. We have a very tight range in this case that we have to stick to, and our lungs and our urinary system works very hard to keep right there. And like I said, it does a fun chemistry dance, which is actually pretty darn cool. And it brings me back one time, and don't get me wrong, I love going into hippie shops. I love gripping all the crystals, even though you're not supposed to touch all the crystals. But I like going into those places. I like all the cool things. Anyway, it's funny to me. But I went into this one, and the lady who was manning the register at the time, I had bought a couple of books because I do Reiki myself. It's type of energy healing, although it itself has its own piles of issues I could go into all day long. So anyway, it was funny because I went in and got a couple of books. I was like, oh, cool. I just like buying books. So I go in, I buy the books, and she starts going on this weird tirade about diet, and that's fine. I don't mind. But then she sat there and said, no, we need to eat nothing but vegetables. And she wasn't exactly vegan. It was interesting. Or vegetarian. She was just going, we need to turn our blood acidic. And that way you stay healthy and no viruses or bacteria can get in your blood. And me being, well, I teach anatomy and physiology and biology. I'm sitting there going, if your blood turns acidic, you die. She's like, no. And I'm like, okay. There's sometimes where it's sometimes you argue, sometimes you just go, okay. And you walk on out the door because it's like there's sometimes no saving some people. So, but yeah, she was insisting, and that's when I talk about, your blood turning acidic and whatnot. And like I said, we stay in a pretty tight range. If your blood truly turned acidic, you'd be in the ER. Which I've been visiting last week a bit too much. I'll get into that when I send out a message to you all. But anyway, yeah, just for the lady out there somewhere who's insisting that we eat nothing but vegetables, not to be vegetarian or vegan, but to turn our blood acidic so that way we can never get sick again. Yeah, that's not how that works. That's not how this works. To quote the Geico commercial, that's not how any of this works. Anyway, so urinary system consists of the following organs: the kidneys, which is where all the fun is, the ureters, which transport urine from the kidneys to the urinary bladder that holds it all, and then your urethra, which basically lets the urine out of your body. So, because what goes in must come out eventually, we've got to get things out just as much as we need to pull things in. Remember, we are a tube within a tube, and it's good. And tubes have a beginning and an end, unless you are a, okay, hold on, I got it. Where'd it go? Yeah, unless you're a sea cucumber. And then your tube is U-shaped, and you have the same opening for both, which I'm glad I'm not a U-shaped tube. Anyway, and I'm probably sure you're glad you're not a U-shaped tube, despite that one horror movie that made everybody go. Anyway, so kidney has convex lateral surface, concave medial surface. In other words, it's shaped like a bean. Now, I have a question, and maybe you guys can look this up for me. I mean, I could Google it too, but maybe put it down in the forums. Yeah, I might make this a question, see if you're paying attention. That is, were the kidney beans named after kidneys, or were kidneys named after kidney beans? I bet you anything it was probably the kidney beans were named after kidneys. But, I could be wrong. So go ahead and answer that wacky question on the forums for this week. I'm curious to see what you guys find. Anyway, and don't use ChatGPT. Oh my gosh. Apparently a couple of lawyers got into major issues trying to use ChatGPT to win a case. And ChatGPT actually invented 3 lawsuits that does not exist. Yeah, so watch out. Some people might think, oh, this is a godsend. It's not. Because apparently ChatGPT lies. It's been taught to make stuff up now. So watch out, because if you think you're using it for research and you don't double check what it researched for you, you could get disbarred like these 2 lawyers. Oh my gosh. So just FYI for those of you that are into, yay, ChatGPT is a good thing. Just watch out, because Yeah, it's making things up now. Anyway, so it has a renal sinus, which is a hollow chamber in the medial depression, hilum, which is the entrance to the renal sinus, the renal pelvis, it's the funnel-shaped sac, superior end of the ureter. It has major calyces, which are large tubes that merge to form renal pelvises, and minor calyces, which are small tubes that merge to form major calyces. The renal medulla, I just like saying that. I think medulla is a fun word to say. Anyway, the inner region composed of the renal pyramids, a renal cortex, which is, of course, the outer region of the kidney. Remember, cortex means outer, medulla means inner. Renal columns, which are extensions of the cortex that dip into the medulla. The renal capsule, which is a fibrous capsule around the kidney, so that way, your kidney doesn't fall apart. And nephrons, which we're going to be talking about a lot. So get used to the word nephron, because we are going to nephron so hard from here on out. So they're the functional units of the kidney, each of which is a site of urine production. And it does it in a really interesting way. So again, to take that list and basically put it into practice, again, we have the kidney shape, which is kind of like a bean shape, but larger. We've got two of these guys. They're on our back wall here. So, like, if somebody does a sucker shot to the side back, I was in karate for years. If somebody checked you right there, punches to the kidney was not your friend. And that's also a no-no shot when you're in, when you're in doing sparring for tournaments. Now, in real life, anything's a good shot when it comes to karate, because usually if you're in a fight, it's usually life or death. And, in the real world, unless you're in, MMA or something, even then, kidney shots are not your friend. Anyway, so again, the renal vein, renal nerve, renal artery coming in, and there's reasons for this, and it actually splits out, and it has these, again, here's the pyramids, although they look more like petals to me, but maybe that's because I'm weird. They're triangular, so that's why they went with pyramids, but they look more like flower petals to me, but they're bigger than that. They're not flat like a flower petal, they're rather large. Anyway, so there you go, what we're looking at. So again, here's the renal hilum where everything's coming in. And then what's coming out, all these pyramids are dumping into the renal pelvis, which then collects into the ureter, and that brings the urine out. So basically what's coming in, blood is coming in, filtering through, and we'll talk about the whole filtering process. This is just an overview. And then it filters through, and then it gets, dumped out into the minor calyx, into the major calyxes, into the renal pelvis, which enters the ureter, and then goes to your bladder, which holds it until it's time for you to go to the bathroom. Or it's time until, your body's had enough, and it's time to do the pee-pee dance, which I think we've all experienced in this life. Anyway, and then, blood leaves, urine leaves. So blood and fluids leave through the vein, cleansed and ready to go around again. And all the things we don't want exit out the ureter when we go to the bathroom. All right, so that's the overview. Let's get into the nitty-gritties. So, renal artery enters the kidney through the hilum, continues to branch of the nephrons, and here you can go down this way, but the ones we really care about that we're going to be getting into is something, so we go from the renal artery, interlobal artery, the aciform artery, the cortical radiate or interlobary artery. Watch out, in this chapter there's like a couple of names for each thing, and that throws a lot of people, so please, like I said, be very careful with the vocabulary in this chapter. You might want to definitely do, some vocabulary that's confusing you or whatnot. Definitely do flashcards. Definitely, if you prefer the online version, make flashcards using what is it? Quizlet. I don't know. There's so many things that start with the word quiz these days on the internet. There's Quizlet, quizzes. Anyway, so just some suggestions of what's going on there. So anyway, glomulus, and we're going to talk about him. That means ball of yarn. He's really interesting. So it basically goes down into an afferent arteriole that enters the nephron, then gets filtered by the glomulus, which is capillary network that filters the blood, which I think is just so cool looking. We'll get there in a minute. And then it leaves the efferent arteriole, and then the tubular capillaries. Now, from the nephron, it goes into the intervolar vein, the archiform vein, the interlobal vein, and the renal vein. There's probably going to be a test question on either the archiform vein or the archiform artery. I remember the word archiform definitely hanging out in the test. I'll have to go look again. Anyway, so just FYI. Blood comes in, gets filtered, blood goes out, all filtered. Now, how do we do the filtering? Well, we use these things called nephrons. And nephrons are kind of made of a couple of parts. And we kind of split a nephron up into two parts. And this isn't the best picture, honestly. I've got better pictures later on. So anyway, what's happening is the blood usually comes in the efferent arteriole and comes into the Bowman's capsule. And inside the Bowman's capsules is a thing called the glomerulus. And your body has a wacky way of doing things. Because, we think of filtering like, if you're looking at cars, if you're a car person or whatever, or if we're filtering water, we force, the water in our refrigerators, or if you have any other kind of filtration systems in your house for water, we force it through a series of like meshes or charcoal things. And it's the same thing when you pull out the oil filter. What is an oil filter if you've ever ripped one open? It's just a whole bunch of, very fine mesh, paper-like material to force it through to keep all the big things back and let all the cleaned out, liquids flow through, right? So that's how we usually think of a filter. Well, our body does it backwards because, I don't know. Again, this was one of those things where it happens and nobody was, exactly asking for thoughts. But the old saying, don't throw the baby out with the bathwater? Well, your body does exactly that. It goes way against that saying and throws everything out. It literally forces everything out, doesn't really filter it so much as it throws it all out, and then we suck back in what we need. And that's what each one of these nephrons do. And they have different parts that suck in different things. And we're going to talk about how it sucks it in. It's usually a clever use of salt, which is why kidneys are actually very salty. And I don't mean, they're grumpy. So anyway, so the glomerulus, again, what happens is here, and you're going to see it's called ball of yarn, and it really looks like it under electron microscope. I think it's one of the prettiest things in the body next to the inside of the heart cavity. And I've got a really cool picture of it in a minute. So anyway, it's called the ball of yarn. That's what glomerulus means in Latin. And basically what happens here is we send the liquid down the nephron. However, all the big things like the red blood cells, the white blood cells, platelets, and even large proteins and whatnot actually get forced back out. So they are actually separated. So we separate the big things out from all the liquid. And that's basically, and not all of the liquid. Some of it obviously needs to go down and carry, the big things, or we'd have a jam right here. But the majority of it gets forced out through here, and that's usually through differentials we'll get into in a minute. So anyway, the liquid then travels down, and what it goes down is usually called the proximal convoluted tubule. And you'll see pictures of this in a moment, or like right here. Look how wacky that thing is. It is like very, 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 it's kind of like a crazy ride. It's very convoluted. That's why it's called the proximal convoluted tubule. Then it goes down through this loop. This loop is known as the loop of Henle. It also has a different name, the nephron loop, but they're adorable. And then through the loop, and then it goes through the distal convoluted tubule. Just when you think you couldn't have more convoluted tubules being convoluted, don't wait. But wait, there's more. So again, the convoluted tubule up in here. And then finally, the liquid actually, and this shows it flattened out, but in reality what happens is there's an area where the blood actually goes back in the, hold on, my pictures, the efferent arteriole to get back into, the veins and whatnot. And I'll show that in a minute. I've got a better picture of this. So the distal actually forces the blood to go back out, but everything left over that isn't being put back into the blood is actually dumped out the distal tubule into a collecting duct. And there's a lot of these nephrons filling into a collecting duct. So that's what all these openings are right here. So more. And they're all, dumping out whatever the body didn't want. And everything is going back out to the vein that we did keep. So that's basically what's happening is we are shooting all the liquid through these tubes and then sucking out of the tubes back into the efferent arterial, the veins, or the capillaries at this point, the capillaries to get back to the renal vein, and then goes back into the circulatory system. So clear as mud. Yeah, I understand. It's a lot. So let's break it down even further. Okay. So each kidney contains about 1 million functional units called nephrons. And each nephron we split into two parts. We call it the renal corpuscle, which is the glomerulus, and the Bowman's capsule, or the glomerular capsule. Again, there's a lot of words in here. Glomerulus means a ball of yarn. The renal tubule is the part with the proximal convoluted tubule, the nephron loop, which is also known as the loop of Henle, because that's just funner to say to me. Funner's not a word. And then the distal convoluted tubule. So, and each of the distal of several nephrons emptying into one collecting duct, which continues down through the medulla and basically goes into the minor calyx, then the major calyx, and then down the ureter tube into the bladder, and then holds it until it's time for us to go to the bathroom. So we split the nephron into the two parts, okay? The renal corpuscle, which is basically filters the blood. It's the first step in urine formation, and we're getting basically the big things away from the liquid part for the most part. Now, there is some liquid that goes with because, you don't want a blockage of all the red blood cells and white blood cells and platelets and proteins just hanging out. So there's a bit of give and take there. But the majority of it goes through the nephron. And like I said, we throw everything out into the nephron, and then out of the, the renal tubular part, which is the proximal convoluted tubule, nephron loop, and the distal convoluted tubule, we suck back out everything we want to keep and put that back into capillaries to go out into the veins. And then whatever's left over, that goes into urine formation. Okay. Let's break it down some more. So let's look at the first step. Isn't this just the coolest looking thing? I think it's neat. I just love how it looks. It's so pretty. It just astounds me that there's over 1 million of these suckers just hanging out in both of my kidneys right now, filtering my blood. I just think it looks pretty. And you probably think I'm crazy, but that's okay. I know I am. And anyway. Trust me, you teach high school long enough, the kids tell you you're crazy. And, good teachers are like, yeah. Anyway, so again, notice here also some structural differences. Notice the afferent arteriole coming in is way bigger than the efferent arteriole coming out. Why is that? A pressure differential. There's way more coming in and not a lot, and it's being shoved down into a smaller to force it to flow. So a whole ton is coming in and it forces it to filter. So a whole lot is coming in, it's forcing it to filter because there's not it's half the size of the afferent arteriole coming in than the efferent arteriole leaving. Isn't that interesting? So your body does a cool trick with a size differential to force the filtration to happen just naturally with flow. Isn't that pretty cool? Yeah. So anyway, pretty cool. Yeah. So then it goes into the proximal distal convoluted tubule. Wait, no, proximal convoluted tubule. Why did I say proximal distal? Anyway, it gets filtered through all these look at these slit pores, and the things that are in between are called the pedicels. Do you have to know that? No, but I'm just showing it out. These things are holding all together, the primary process of the podocyte. I just think that's cool. I love these slit pores. I just think they look so pretty. They're so pretty. I know you're probably like, oh God, she's lost her mind. But I lost it years ago, and I look behind the couch. It's not there either. Anyway, So now let's talk about the nephron. Let's talk about after the filtration happens, what basically is the fun time. And you'll notice that the distal convoluted tubule bumps up against the afferent and the efferent arterioles right here. There's a reason for that. That's actually where a lot of the liquid is coming back out here to force the big stuff down the way. So the red blood cells, the white blood cells, all those big things that can't get through the glomerulus for good reasons, because we're filtering the liquid right here. We're not filtering and the liquid is called your, it's not just your plasma, but it's more than that. We'll get into that in the next chapter. So your interstitial fluids, if you want the technical term, but I'll just call it the fluids for right now. So anyway, so what happens is the filtrate leaves, and the big stuff goes down the efferent along with, some of the liquid that's already been filtered, because the distal is actually bumped up right against. So like I said, we usually show it kind of like flattened out a bit, and like this not so hot picture right here, but in reality it kind of loops around. Gee, it's probably why it was all named loopsies. So anyway, so the proximal convoluted tubule, so again it goes wee all around that, and what we're doing is, again, this side is usually sucking things out, usually through diffusion and whatever else. And there's something that we're going to be talking about, is that water follows salt, and it really does in your kidneys. So a lot of the times when we try to take water back, we're usually doing it around the loop, and we'll talk about that in a minute. And the water will follow the salt. So if there's a higher salt concentration out here than there is inside, the water will naturally come out. However, there are hormones that make these, like the distal convoluted tubule, susceptible for more water to come out. And that's where our friend antidiuretic hormone comes from. Remember I said at the beginning of the semester we're going to talk about him again? He's back. So antidiuretic hormone actually makes distal convoluted tubule basically either impenetrable water or penetrable water. In other words, it lets water out, or it tells the water to stay put. And alcohol can actually get in the way of this, which is why we're going to talk about that in a bit. So I'm not, better not jump the gun here. So anyway, and we go through the proximal, and then we go through the loop of Henle. Now the descending limb does different things than the ascending limb, which is going back up. And actually, this actually dips down into the medulla. So those renal pyramids that we talked about earlier, yeah, they're back again. So this top, and you're going to see this in a picture in a minute, this top part usually is sitting on top in the cortex of the renal pyramids, and actually the loop dips down into the pyramid, which is kind of cool. So we'll get there in a minute. And then the distal convoluted tubule, which is basically last takes. Also, again, we can pull water out of this depending on how antidiuretic hormone is working out that day. And then it dumps into a collecting duct, which then, a lot of these guys dump into that collecting duct. So as you can see right here, again, these guys are sitting in the renal cortex, as I pointed out, and the loops dip down into the pyramids, which is actually kind of neat. And there's reasons for that, salty reasons. And then again, it comes up, and a lot of these dump into, and then go down into the minor calyx and down and in. So anyway, there's two flavors of nephrons in the kidney. There's the cortical nephrons, and these guys sit really high in the cortex, which is why they're called the cortical nephrons. So you can see right here in this picture how high up he's sitting, and he's got a short loop. These are the majority of your nephrons in your body. And I know it seems weird, because the next thing I'm going to say is make you go, well, why don't we have more of those? Again, I don't know. I wasn't there for that one. Another type is the one that has a really long loops and sits very low, basically right on top of the renal pyramid, or the renal medulla, and that is the juxtamedullary nephrons. Juxtamedullary. That's just crazy word. Anyway, and he sits low in the cortex, and they have really long nephron loops, and they're very important for regulating your water balance and your urine concentration. However, we don't have that many. They're a small percentage of the overall nephrons. And you might be going, well, why? Good question. I'm not entirely sure. Feel free to look that one up. Again, don't do it through ChatGPT because that thing makes stuff up. Like, anyway, it makes it up. So don't trust answers out of ChatGPT right now. I don't know. It's learned how to make stuff up. Whoever built it put in a make stuff up thing now, and it's doing a good job of making stuff up that isn't right. So anyway. All right. So this is what basically, if you remove everything but the arterioles and the venules and the capillaries and the nephrons. Isn't that neat looking? Just looks like, I don't know. This is neat. All right. Anyway, so the juxtaglomerular apparatus. Just when you thought we couldn't have any more apparati. Anyway, this is the structure that regulates the secretion of renin. Now, the top portion of the ascending limb of the nephron loop each passes between the afferent and arterioles. So, in other words, what we're talking about is right here. So, here's the afferent arteriole, here's the efferent arteriole. This part right here bumps up. And there's actually a basement membrane in between. So, at this point, the ascending limb comes into contact with the afferent arteriole to form the juxtaglomerular apparatus. At this location, both cells are specialized. So you got the macula densa, these tall, tight, closely packed cells of the ascending limb, and the juxtaglomerular cells, large vascular smooth cells of the afferent arteriole. So again, we look up right here. This is what I'm talking about. So again, notice the afferent's coming in and the efferent's leaving, and this part right here, this is the apparatus we're talking about right here. And you'll notice here's the distal, here's the afferent, here's the efferent, and the juxtaglomerular apparatus is right here. Basically what's going on is this way liquid is not accidentally seeping out of the afferent because it needs to go in to here and be filtered, but liquid can seep out from the distal into the efferent, so that way it keeps everything flowing and we don't have a blockage of the big boys, you know, the red blood cells, the white blood cells, yada yada yada. That's why he's there. That's why we mention this juxtaglomerular apparatus, because it's preventing leakage. So that way, but you don't see it right here, so that way liquid can get through, and therefore it flows. When all the big things are shoved out, it flows down. So you don't have a blockage. Does that make sense? I hope, no? Yeah, okay. Ask one of my cats. Hey, Sonny, does that make sense? He's staring at a squirrel. Anyway, I think that's a squirrel. I don't know, he's staring at something outside. I have to put corn out for the squirrels. Now, we're going to get into that more in the next section. But before then, let's go ahead and talk about the lifespan changes. So the urinary system has sufficient reserve in both structure and function to mask age-related changes. So kidneys are actually kind of interesting. They stick it out, man. Except, unfortunately, I do know some friends that are on the kidney transplant waiting list, and I'm hoping he definitely gets it. Anyway, so kidneys become slower to remove nitrogenous waste and toxins to compensate for changes that maintain homeostasis. So kidneys can appear to be scarred and grainy due to connective tissue accumulation. Kidney cells die. By age 80, the kidneys have lost a third of their mass, which is why, you know, like my grandparents, who also accidentally not accidentally, ended up in the ER this past week. I've been having too much ER fun this past week. Anyway, yeah, that's why, you know, my grandpa, he's in his 90s and we can't really go anywhere with him because he can't leave a bathroom for very long. And this is the exact reason why his kidneys are working, but, you know, he has to go quite a bit. So kidney shrinkage is loss of glomuli, loss of surface area for filtration. So decreases basically your glomerular filtration rate. That's what that GFR. We're going to talk about that in the next part in just a moment. And by half by age 75. Proteinuria may develop, renal tubules thicken, reabsorption of nutrients and ions becomes less efficient, so you're not sucking back up what you need. It's harder for the kidneys to clear certain substances, and blood flow to the kidneys slows, bladder, ureter, and urethra lose elasticity, which can lead to incontinence. Bladder holds less urine, and kidneys are less able to activate vitamin D. So, because we do need vitamin D, and one of the interesting places that we get it is actually we synthesize it from being out in the sunshine for a bit. Now, I'm not saying go out there and go get a tan, because I don't, because if I get a tan, I go straight from my pasty white complexion to burnt. Anyway, and so, but still, go out for a good 15 minutes. Anyway, it's good for you. It's good for you. A little bit is good for you. Anyway, again, especially with the urinary system here, watch the videos. It really helps to visualize this sucker, because there's a lot of things going on, and we're going to cover that in the next half, and then we're also going to cover it even more in chapter 21. So please, please, please definitely watch some videos. I have these two linked. I don't know if I have a Bozeman science video linked. I should probably link one. I'd have to go look to what I've got linked down in the thingy. Anyway, with that said, I'll say goodbye to you for now, and I will see you in the next video. So, goodbye.